8th grade, we are on math lesson 4.1. This is representing linear non-proportional relationships. In the previous lesson, they talked about proportional relationships. Those were represented by straight lines because you have a constant thing going on and it's the same value, increasing by the same value or decreasing by the same value over time. But those proportional relationships always, that line always went through origin, through zero, because there was no initial amount to start at the starting point. So let me put it as an example. I want you to kind of get familiar with this setup. So I'm going to write this as y equals mx. This is just kind of telling you where things are going, and I think I did show you in the previous lesson, where this is an amount, a value of something. This is the slope m I talked about, and depending on what happens between these two, that they will equal that, y equals mx. Proportional relationships would look like this. So let me use an example to help make sense of it. Let's say I had something that's represented by y equals 3x. Maybe we went to the fair. They didn't charge us to go into the fair, but they charged us $3 for every ride we went on. Every ride we went on was $3. So the 3 would represent the amount of money I spent for every ride. Y would represent how much money it cost me. So if I went on one ride, everything cost me $3. If I went on 2 rides, 3 times 2 is 6, everything cost me $6. If I went on 3 rides, 3 times 3 is 9, everything cost me $9. That's what this is talking about. Notice there's nothing over here. On a proportional relationship, you'll have nothing over here, or maybe you will see plus 0. Let's go back to that fair analogy. It was $3 for every ride, x representing the rides, y representing how much it cost me. But they didn't charge me anything to get in the gate, the one-time fee to get in the gate. If they did, that's what this would be. So that's where we're at a difference. For proportional relationships, there was no initial cost of something maybe. It's going to go through origin. If this is a plus 0, our straight line is going through origin because there's no initial upfront cost or amount. A non-proportional relationship simply is that, or I should say a linear non-proportional relationship, is something where you're going to see a continued straight line. The only difference between it being proportional or non-proportional is that it's not going through origin. There was a cost up front at the fair. To get through the gate, they charged you $5. Okay, so maybe now that's $5 and then $3 for every ride. Something like that. So it's a very slight difference. When you look at a graph, you're going to see if it's proportional, you're going to see a straight line going through origin. But a non-proportional will be a straight line that doesn't go through origin. A linear non-proportional relationship will show as a straight line that does not go through origin. So those are the differences you're going to be seeing in this lesson. This is very foundational for the next several modules that we're going to be doing in math. So make sure you're understanding all the pieces of this as I go through it. Use the notes that I've provided, ask questions of your teacher, of me when we are in our workshop together, or send me messages asking me the questions that you need to clarify. But you're going to want to understand this inside, outside, and upside down. So the first example they give us is talking about going bowling, and most of you have probably gone bowling before. You know you have to rent their funky shoes, and you only rent them the once, right? They don't charge you a rental fee of the shoes for every game you bowl. It's just you go in, you pay one time for the rental of the shoes for the whole day that you're there. But they do charge you for each game you play. Like you play one game, you finish it, you won, of course, because you're good at bowling. And then your friends say, let's play another round. And so then there's a fee for the next game, and they charge you for every game. So let's talk about what that looks in that equation that I was showing you. In this example, they gave us the equation. But I want you to understand so that you can translate back and forth between English and Math-ese what each of those numbers represent. So we'll use their equation that I really want you getting familiar with. You really need to memorize this. Y equals mx plus b, x and y being the coordinates that you've been familiar with since the 6th grade when we taught you coordinates, the XY coordinates on a graph. M being the slope, that's the value that changes for every something, in this case, every game. And the B being the y-intercept, I'll explain that in more deeply later, but the y-intercept, that's that cost, that's the one-time fee, in this case, the shoes, right? So let's go ahead and write this in y equals mx plus b format. Y, the cost, total cost of my day of bowling is going to equal the $3 for every game I play, 3x, where x represents however many games I play. We don't know yet. It depends on how many times my friends say, let's play again. Plus the $2 fee for my shoes, that's only a one-time fee. Okay, again, in the example they gave that to you, but I wanted to translate that for you from information in English to math-ese. So this is something you will become very comfortable and familiar with practice. All right, so let's see what we do with this information so that we can graph it. Remember, when we graph, we like things in x, y coordinates so we know which points on the line those are. So I'm going to take you there. They gave us tables in that page 97 for that, but you'll go to using those tables eventually, but I'm going to alter that table a little bit so that you could see every step that's going on and your brain can make sense of it. And maybe you just keep the way I do the tables. If it makes sense to you, keep it. But after you see what's going on, you probably won't need to do it to that level again. I kind of make them up and down. And I put my x's here, my y's here. And then I put our XY coordinates here because that's our goal, is to find out what points are on the line, okay? I take this part of the equation because it equals y, so equals y. I take this part of the equation, 3x plus 2, and I put it here. That is 3 times whatever x is plus 2. All right. So I just need to kind of come up with how many games we're talking about. So we're going to say, what if x equals 1? What if x equals 2? What if the amount of games I bowled was 3? And what if the amount of games I bowled are 4? How much money would it be? So I'm going to push that into my equation. So it's 3 times x plus 2. The equation stays the same, notice, but in this first one, x equals 1. In this second one, x equals 2, so I'm going to put 2 there. Then what if x equals 3? Then I'll put 3 there. What will y be if x equals 4? I'm going to put 4 here. Now I'm going to calculate my y's. So if x equals 1, 3 times 1 is 3 plus 2 is 5, y will equal 5. If x equals 2, then in this equation, 3 times 2 is 6 plus 2 more is 8. Y will equal 8. If x equals 3, then I plug 3 into this equation. 3 times 3 is 9, plus 2 more is 11. And if x equals 4, I plug the 4 into this equation. 3 times 4 is 12, plus 2 more is 14. Now, this is the easy part. I'm going to go ahead and write these in my xy coordinates. So I have, when x is 1, through this equation, y will equal 5. 1, 5. When x is 2, run through this equation, then y will come out as 8. My coordinates will be 2, 8. When x is 3 and it runs through this equation, y is going to turn out to be 11. 3 games bowled cost $11 total. When x is 4, the amount of games we bowled was 4, run through this equation, then the cost was $14. When we bowled 4 games, it cost us $14 based on that equation. From there, I can go ahead and graph that. I'm going to do a tiny graph Sorry. Okay, so here is my graph of x coordinate, or the x number line 1, 2, 3, 4. The y-axis counting by 2s, 2, 4, 6, 8, 10, 12, 14. When x is 1, y is 5. 1 on the x, turn and go 5 on the y. Positive both. Positive 1 on the x, turn and go positive 5 on the y, which is going to be about right there. Go 2 on the x, turn and go 8 on the y. 2 on the x, turn, 8 on the y, right there. 3 on the x, turn and then go 11 on the y. 3 on the x, turn up to 11 on the y, about right there. And 4 on the x, turn, go 14 on the y, right there. And we'll have a straight line. Let's pretend that's straight. Thanks for your imagining that. That goes through positive 2 on the y-axis. That's why we call this the y-intercept. The y-intercept is where this linear equation, but not proportional because it doesn't go through origin, goes through the y number line. This is where it happens. It goes through the y-axis at positive 2. So we call that the y-intercept. That's where it intercepts the y-axis. And you could always know too, that's the initial fee or the initial cost, the rental of the shoes in this case. The next example they take us through is we're at an amusement park and they charge us $20 to get in the door, and then or in the gate, whatever. And then every ride is $2 per ride. A ticket for the ride is $2 per ride. And so we don't know really how many rides we plan to ride. Depends on what kind of cool rides they have, right? So this is the variable amount. I'm going to spend $2 on every ride, but I don't know how many rides I'm going to have. This is the for sure amount, the $20 that I have to pay just to get through the gate. I don't go through the gate multiple times. I go through the gate once, and then I go on however many rides I want. So I will set that up in our formula, y equals mx plus b. Again, they gave that to us, but I want your brain to start seeing how that translates. So the variable amount, again, is how many rides am I going to do? That's my x. How many rides am I going to do? For however many I do, right now I don't know, but I do know it's going to be $2 for each one. So that becomes 2 times x, however many rides I ride. They charged me a fee to get in the door. That's not going to change. It's $20 to get in the door. How much is the whole thing going to cost me? Well, I don't know yet because it depends on how many rides I want to ride. Ignoring food and everything. We know that you're going to spend money on food, but let's say food isn't involved here. So how much will my day at the fair cost me? Cost is this. However many rides I ride, it's going to be $2. Plus, I had to pay the $20 constant fee, the one fee that I had to pay to get in. All right. So they put it on a table horizontal, like I mentioned before. But instead, just to give your brain that chance to understand what's going on, I'm going to use this organizer rather than that horizontal one that they have there, so your brain can see everything that's happening. So let's say the amount of rides I went on was 0 because I didn't want to throw up. Or maybe I only went on 2 rides, x equals 2. Or maybe I only went on 4 rides, x equals 4. Maybe I did 6, or maybe I did 8. So for any of those scenarios, let's go ahead and solve and see what the cost would be. On the first one, if x is 0, then I'm going to run it through that 2x plus 20, where now x is 0. 2 times 0 plus 20 is 20. When x is, I should have made that red, sorry. When x is 2, if I went on 2 rides, what's my cost going to be? 2 times 2 is 4, plus 20 is 24. If x is 4, if I went on 4 rides, I want that red. 2 times 4 is 8, plus 20 is 28. If I went on 6 rides, I'm going to put that there. 2 times 6 is 12, plus 20 is 32. I want that blue. And if I went on 8 rides, run it through the equation. 2 times 8 is 16, plus 20 is 36. Now I'm just going to take this row of x's, put it next to this row of y's like that. So I have my coordinates for my graph. Okay, so when x was 0, y was 20. X is 2, y is 24. So I just carried them all across. And now I will go ahead and graph each of these coordinates. Go 0 on the x turn and go 20 on the y. 0 on the x, I'm not side to side at all. 20 on the y will be right there. I'm going to mark that spot. It's the point, well, I'll get to that in a minute actually. I'm getting ahead of myself. 2 on the x, turn, go 24 on the y, mark the spot. 4 on the x, turn, go 28 on the y, mark the spot. 6 on the x, turn, go 32 on the y, mark the spot. 6 on the x, 32 on the y. 8 on the x, turn, go 36 on the y, right about there. Forgive me for not having graph paper and not having a ruler, but there we go. Kind of a straight line. Pretend that's straight. It'll go on and on. And what the line represents is, for this equation, every single point on the line is a possible answer for this equation, depending on what x is, even the in-betweens of decimals and fractions. So these are all possible answers. Instead of calculating them all, it's so much easier just to draw the line and say, oh, these are possible answers for x. I'll find 3 of them, I draw the line, now that you've got them all. So that's why the arrows. Where the line intercepts with the y-axis is my y-intercept. That's what we're really going to be getting into. And it represents our initial cost. So we know when we have gone on 0 rides, it cost us $20 in the first place. That was our starting point. When we had proportional relationships, it went through here, the line did. That meant there was no initial cost. It was just what the costs were afterwards for each thing that you did. In this case, we had an initial cost of $20. And then for every ride we went on, this is the possible amount that we spent. Okay, so the last example is talking about this tree that is going to grow over the next 50 years. Their initial measurement, when they first measured, was 10 inches in diameter. Then it's expected to increase by 2/5 of an inch every year. So let's translate that. I know they gave you the translation already, but the practice is important. The amount that isn't going to change, that's always going to be that amount, was the first measurement, was 10 inches. So we're going to put that as our y-intercept, 10 inches. What's going to change is this every year part. X is going to represent that every year. And it's 2/5 of an inch for 1 year, and then 2/5 of an inch for another year, and then 2/5 of an inch for another year. So it's going to be multiplied by however many years we're talking about. So we put 2/5 there. So our equation is y equals 2/5 x plus 10. I'm going to write this part of the equation here. Notice this time around I put the table that they use in the book here, just so you could see now the translation to both, but I put the way I've been showing you here. X here, y here. The part they don't show is where the calculation with this is happening, and I feel like that's a bridge that needed to happen with students I've worked with in the past. So now I'm writing this equation right down here. And I'm going to plug in the x here where x is 0. I'll plug it in here, 10 here, 20 here, 30 here, and 50 here. I am going to, though, I'll show you what I'll explain as I go. Here I'm going to put 0. Here, because I have a fraction here and I'm going to multiply the fractions, I'm going to go ahead and make that a fraction 10 over 1, and I'm going to do the same 20 over 1 for the rest of these. And then I multiply across. I have 2/5 times 0, which is 0, plus 10, so the total is 10. Here I have 2/5 times 10 over 1. If I cross reduce, 5 goes into both of these, and that's going to be the nice thing about each of these. That fraction is going to be eliminated out. 5 goes into both 5 and 10, once there and 2 times there. So I'll be left with 2 times 2 is 4, plus 10 is 14. This is going to cross reduce out, leave me with 1 there and 4 here. 2 times 4 is 8, plus 10 is 18. This cross reduces here. 5 goes into 5 once and then goes into 36 times. So 2 times 6 is 12, plus 10 is 16. I take that back. That was not right. 5 goes into 5 once and into 36 times. 2 times 6 is 12, plus 10 is 22. And then 5 goes into 5 once, into 50 10 times. 2 times 10 is 20, plus 10 is 30. And those give me my x, y, x, y, x, y. So I'm going to fill those in over here. All right, so I have filled those in. I also took these, see, these were the x's that we dealt with here, and then this is the y we got when we run it through the equation. So that's what goes in those spots. They're just not showing you the calculation in between like I did here. That's why I kind of started you here. Eventually you'll just maybe put it in a table this way because you know what calculation you need to do. But until then, use this to kind of guide you through. Now I'm going to go ahead and graph it. I notice as I orient myself with their graph, it's counting by 4 for every hash mark, so it's important to know, and over here counting by 5 for every hash mark. 0 on the x, turn, and 10 on the y. 0 on the x, turn, and 10 on the y is about right there. That's my y-intercept. My y-intercept is where it goes through the y-axis, the initial cost of $10, or the initial measurement in this case of 10. Then I have when x is 10, so after 10 years, y will be 14. It will have grown to now 14, so 10 on the x turn. Go 14 on the y. That's about right there-ish. I don't have graph paper, but there we go. When it's 20, I'll mark off those spots. Okay, I marked off those spots in interest of time because this is getting long. I didn't do the 50 because I didn't have the 50 on here, but that's fine because it's going to be in that line. Draw the line. Every answer, or every point on that line is a possible answer for this equation. So instead of writing them all down, we drew a line. That's my straight line. Y-intercept at 10, 0 on the x, 10 on the y. There you go. We'll practice this. It will become easier. Very important you understand this well, though, so make sure you ask if you're unclear.